There was a moment a few years ago, before all this seriously began, when I threw away my civil engineering notes. 4 years worth of work that I'd done on how to pass a degree and get a first, I threw it away. In the moment that I did so, I pulled something from the flames. So I was casting all this knowledge that I crafted, throwing it away, saying it has no value. And then I pulled my thesis, a rough draft copy of my thesis from the flames, and kept that. When I rediscovered that document then, a couple of years after I'd done that deed of throwing away my notes, and I realised just how important this was, this document that I'd done, this research into Lewe, proving that the library in the Institution of Civil Engineers in Great George Street has been tampered with, and that the catalogue's been altered since 2008. I referenced the catalogue, directly referencing it, saying, this entry is wrong in your catalogue, it should be this, and giving them the correct, as far as I could see, Harvard reference, that's how it should be shown in the catalogue. So an absolute cast iron piece of evidence that proved that that entry was in the catalogue in 2008, and now it isn't. And the documents aren't on the shelf. When I realised this document was that important, I was determined to come up with why. I had to prove it. From an engineering perspective, I understand this concrete tank Leweian model of the cylinder of water. I understand what Lewe's done, but I don't quite. So Lewe's, what he's doing is, you get a sphere of water, and you say that sphere is hollow. It's a rigid body with a membrane, an elastic membrane, but it's a bubble maintained for a duration. How do you analyse its strength? And you turn it into a sphere, into a cylinder. You simplify it to a cylinder, and then I believe that you cut the cylinder and unwrapped it, and then you could get it. You've got a two-dimensional plane on which you can then use coefficient tables to determine the instantaneous forces from the centre, from the bending moment, in each point on the surface, simplified as a sphere in that way. But what I was doing was just dragging from the poles, and I'm just extending the poles, you see, turning the cylinder that way, the simplest way, just turning the sphere into a cylinder. But that's not the way that you do it. And in understanding how it's done by Lewe, I understand how science does it using Einstein, and I'll show you the difference. Because Lewe's model has the motion in it, Einstein's doesn't. It doesn't have any motion in it. You take a sphere of water, you analyse its strength using Einstein. You take the centre of the sphere and you drag it into 8 corners of a cube, forming a framework of corners of the cube, and then you assemble a hypercube down to the centre, and that the surface area of the windows of the hypercube, those triangular surfaces that are created from the boundary of the cube pointing at the centre, those webs, like a Maltese cross, that surface area is the same as the surface area of the sphere. And now you analyse the strength of the surface membrane using straight lines as a hypercube. But in order to maintain the hypercube, you need to set the centre. So a hypercube has a cube at the centre, of a tiny dimension in this case. And so this is the problem using coefficient tables. You can always get another number in between. Always. If 2 numbers, there's always another number in between. Pi goes to trillions of numbers they've determined, and it keeps going. And so they've determined that they've just said, well, at that point, a trillion digits will stop there. And then there's the cube at the centre, and that cube is so tiny that to all intents and purposes it doesn't exist, it's just a dot. But nonetheless, you've constructed a physics based on it. And so if that's not right, you're going to be missing something, and you're missing the motion. So that's one way of turning a cube inside out into a hypercube, and then you use a 4-dimensional matrix at the centre of the hypercube of numbers, and that's a quantum computer. The simpler model, the Leweian model, is to take the sphere and just grab your hands top and bottom of the sphere, pull it apart, at the splitting the equator at the centre and turning it into two hoops with cones in between them, joined by a cone at the meeting at the centre, and that the surface area of those two cones is the same as the surface area of the sphere. So, okay, you find that they're imbalanced and that the hoop at the top is bigger, based on pi natural, the 3.144 with a solid modulus, and then another 3.144 repeats. So that's those digits, integers in the centre that are the solid modulus, and so the hoop at the top is bigger. The whole thing's in rotation, is in motion, but by doing this stretching from the centre of the equator, turning a sphere into a cone, you can now just apply the twists and it will make sense. So it's a 4:2 to -1 ratio of twists, -1 being a clockwise, a part of a clockwise rotation, a tick, 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 yeah, tick of the clock. And so the top cone is twisted 4 times. 1, 2, 3, 4. There's friction at the centre, but it's not perfect because it's in motion. The bottom cone goes twice, 1, 2. The bottom cone, 2, that cone is spinning at velocity c. So speed of light creates the bottom cone, frame of reference, c. It is in motion, but you don't need to know that. It's just a vortex. It's twisted twice. The top one's twisted 4 times, anti-clockwise. At the centre, it breaks. But as soon as it breaks, the twist grips it. It grips, and the twist is maintained. So that the 4 twists at the top of the cone are always maintained. So it's not faster than the speed c, but it's an energy stored elastically by the motion c. The motion of light itself is stored in the memory elastically. And that's the Leweian model now. So now you can just draw top and bottom, draw straight lines on either side of the cone, top and bottom, and you find that there's not a straight line, because the top hoop is bigger than the bottom hoop, 3.144 to 3.142 with elastic pi in the middle. When we measure, there's a bending, and that bending force is at the top. It's pushing it over, and now you've got a triangle energy of potential. You've got a head of water over a potential distance, and that is realised as the water fall. It rises. So the motion of water from the infinite ocean into the cavitation to sustain the surface, there's a leakage in at the centre, and it's there at particle scale as water enters from the ocean in which we live. We live inside a cavitation of water. So what we're seeing the galaxies, is the outside of our bubble getting smaller and smaller, scratches on the surface of the bubble, as it were, twists in the fabric of space and time. Hi, all right?
Yeah,
Hey, Leslie. Right, I'm going. See you later.